Muy buenos días, Barcelona. So my name is Frank Munz. I work as a technical evangelist for the German-speaking countries, Germany, Austria, Switzerland. So it's a great honor to be invited to Barcelona. I always wanted to visit KubeCon, so it's fantastic to be here. It's also great to see the huge interest in this topic. I hope the magic didn't make you to stay after the coffee break. It's actually just the opposite that I want to do in this presentation, is cut out the magic and explain a little bit of the why and how we do service mesh. So that's the purpose of this talk. And it's a very technical talk. It starts slowly. I have to put some things together. And then I want to give you the full picture, why AppMesh and how AppMesh. And to explain you this even a little bit more, I want to take you back in time to a time before microservices. Do you remember that time? Some of you are laughing. That are the people in my age probably. There was such a time, and I took this black and white copy from a book. It's a book about early clouds and service-oriented architecture. And at that time, we had those monolithic systems, applications that had an API, that exposed an API, and we had to make them talk to each other. And we already understood that having point-to-point connections is not going to make it. You know why? Because then you have this square complexity. If you connect, just 10 services to each other with a point-to-point connection, it's not going to work. So we put this bus in the middle, like the ESB. And the trick of the ESB was it's exposing the API of the service at the ESB, and we changed the client to talk to the ESB, and the ESB would then forward the call to the service implementation. So it's kind of intercepting this call. And the whole architecture is working really well, and I can list you like a dozen of companies in Central Europe that do exactly this or did exactly this like 10 years ago. And I did a couple of projects. And very often we call this ESB also a little bit academic service virtualization layer. And just keep this in mind, it's becoming useful later. So it reduces the complexity, it implements a veto pattern, it validates, enriches, and transforms the messages that go through the bus, and then it operates on the messages. So you could have a condition that says, if this header or this payload or this transport protocol, then don't go to version 1, then go to version 2. So there was a lot of, I don't want to call it magic, but there was a lot of things in this ESB already. I want to call them cross-cutting concerns, like versioning, monitoring, security. Now, I did, as I told you, a lot of these projects, and then I kind of wondered, how does this work together with the new world of microservices when you don't have a single monolithic backend, but maybe a dozen or hundreds of services? And that's a fair question. For a long time, honestly, I didn't have an answer. Now, one question is, could you just keep the big monolithic service bus? Is it bad because it's monolithic? And the answer is no, not really. There is some kind of impedance mismatch, but it's not per se bad because it's monolithic, I would say. One thing that was often sold as an advantage for this ESB architecture was that it is configuration-driven. You don't have to restart it normally, mostly, if you change configuration. If you tell this operation people, what will they do? They will tell you, well, if it's mostly not necessary, then I will restart every single time in production. Now think about using the same monolith for 117 microservices and you restart it every time you want to change something. It's not going to work. Okay, let's just keep this in mind and fast forward to today. You're all building microservices, don't you? How do you build them? How does a modern application architecture look like from a technical architecture perspective? What are the building blocks? Well, it's KubeCon. No, it's containers, obviously. It's all containers? No, it's not all containers. If we are fair, there is serverless, there is AWS Lambda, and we had these discussions many times, like when should you go to Lambda, when should you use your containers? And certainly Lambda gives us the higher abstraction level. It makes things easier, but it's not suitable for everything. So there will be containers and there will be Lambda. And then I get a lot of questions because I spend a lot of time in the container space, and people still say, So now I have this MySQL little database application, and can I put MySQL in a Docker container? Of course you can. The thing is, should you? And the answer is, well, it depends. If it's suitable for your use case, if it's a small use case, well, maybe do it. If you want to have this working across regions, across availability zones, maybe for 64 terabyte of data, multi-master, with 6 copies of your data, and you want to build this yourself, never do it. No, if there is a cloud service for it, like AWS Aurora, use the service, problem solved. That's very easy, no thinking. So we have containers, we have serverless, and we have all these 165 other services that we offer as of today. Is that it? Not really. There's one thing missing. It's EC2. It's still around, and it will probably stay around for a while. And also keep this in mind just for a number of minutes, like 5 minutes. So the old ESB, SOA architecture, those classical building blocks. Now, if we run containers, we have challenges for running containers at scale. I spend a lot of time talking about Docker, showing Docker at conferences, and I pled guilty for, starting up 100 Docker containers in a for loop on my small little laptop and tell people, look, this is how it scales. But that's not the thing. That's not how you can run Docker in production. One problem is that those containers are very transient. They go away, they come back. How can you keep track of what's happening? How can you monitor them? The other thing is the containers itself and the networking is becoming increasingly complex. So it's a distributed system in its own. It's complex. And even the scheduling is a cool question. So if you have 1,000 containers running across machines, where would you put the next container in a sensible way? And that's not something that you want to decide for yourself. And then we tend to forget, because we live in this illusion that Docker gives us, that Docker is not virtualization. No, it's just isolation. It sometimes feels like a virtual image, but it's not. No, it's just this little bit of magic created by C groups and namespaces from the Linux kernel. And we are fooled and tempted to believe it's virtualization, but it's not. It's just isolated processes that run on one host. And what happens if this host goes down or needs to be patched, or if somebody logs into this host and is super user and kills your process. So there's a lot of things that need to be addressed, and probably you need to reschedule containers, schedule containers, and so there needs to be tooling. So one thing after the Docker period was that we learned after understanding Docker was that Docker is not enough. We need more. So there needs to be some tooling around it. And we built this tooling for you. And it's actually ECS. You'd be surprised now. At KubeCon, I talk about ECS. Now, ECS is the orchestration service that we built, which is probably the easiest one if you want to get started with containers today on AWS. It integrates nicely with the entire AWS platform. It scales to very, very large clusters. And it provides service integration like ALB and the network load balancer at the container level. So if you want to get started in a very easy way, that's the way to go. And this could be the end of the story, basically. But then Kubernetes came and entered the stage now. And we all like Kubernetes, isn't it? That's why we're here. That's why we're in Barcelona. So I started to look into Kubernetes like 2.5 years ago. And I was super eager. I had some, system architecture background, strong Docker background. I understood Linux. And I bought like 4 pieces of hardware. I have to admit, it was just 4 Raspberry Pis. And I built a small cluster. And I was like, with all my Docker knowledge, I thought, now I'm going to run Kubernetes and show it in the conferences. And it was like Christmas 2 years ago. And I miserably failed now with all my operations background and Docker background. And I understood it's not that easy to really run Docker in production. This is quite hard. Now, you have to have operational knowledge of, running Kubernetes in production. You have to have operational knowledge of running Kubernetes. And you cannot give this to an operations team that is basically restarting processes if something goes wrong, killing them and restarting them. This is not going to cut it. And that was the next learning that we had, when we understood like the demos that we do with Minikube on one computer It's not like the real thing in production. So we spoke to a lot of customers, and the customer said, we understand we can run Kubernetes on EC2, but then they had the same issues that I had. No, they had to have a lot of operational knowledge, which very often they hadn't. And those customers said, couldn't you run Kubernetes for us? And that's basically what we do with EKS. And EKS is a managed Kubernetes service that we offer. So it's a fully managed control plane. It's multi-availability zone. It's the right-sized master setup. It solves the difficult problems like making etcd highly available. Etcd is where Kubernetes is storing the state. So we give it provisioned IOPS, we back it up, we restart it if something goes wrong, and we have snapshots. Now the worker nodes, you bring them yourself, which gives you a lot of flexibility. You can put them in an auto-scaling group. You can have spot instances that save you like 70 or 80%. You can have GPU instances where a lot of people at the beginning say, why would people do that? But then there is a lot of machine learning currently running on Kubernetes. So all this makes sense, and you have all this flexibility. And then at the end, you connect it to this managed endpoint. And because it's standard Kubernetes, upstream Kubernetes, you can use your standard tools like kubectl and whatever. Now, thank you for being patient. Now let's try and put all these things that I was trying to explain together. Why would we still need this service mesh? That's a good question. And remember when I told you about the ESB? Sometimes this ESB architecture, we like to call it dump endpoints, intelligent pipes. Because the intelligence is in the pipe and the ESB is counting as the pipe because it's on the way between the services. So all these cross-cutting concerns that the ESB is implementing happens in the ESB. It doesn't happen on the client or on the server side. And I was criticizing this approach a lot. I said, it's heavyweight and monolithic, but it did have its advantages because it worked for all kinds of programming languages. It allowed you to use lots of different protocols. You can mix and match like SOAP and JMS and REST and even FTP. So that was not bad in this perspective, but it has these challenges with, we have to restart it. It's too heavyweight. It's too monolithic. Now, one question is, how could we solve the same problem? And what's a more modern version of solving the same problem? And there is this Netflix open source software center that you all probably know from the Hystrix library that implements the circuit breaker pattern. And if you do this, and this was I think most popular 5 years ago, I would say, you get a lot of logic that tries to compensate for a not perfectly working network with circuit breakers and retries and whatever. But you put this logic into the microservice itself. There's a library that Netflix made open source, and you can just use it. And how is this approach, if you think about it for a while? I remember seeing job ads 5 years ago where it said looking for a cloud developer, but you have to have a strong knowledge of those OSSC libraries, and you have to know how to implement this. If you tell your manager to move from a software that you have running to the cloud, you have to implement those libraries. It also means you need to change your source code to make them use the libraries. That's a lot of investment now. Also, these libraries, they probably don't exist for every programming language. The Hystrix one is Java only. What if you want Scala or Go or Rust or whatever? So you kind of have these limitations. I think the strongest one is to change your source code to make it use the libraries now. Is this the real way to get custom software into the cloud? I don't really think so. Now the question is, couldn't we have something better? Maybe the best of both worlds? And the answer is yes, and you can guess it's a service mesh. So the service mesh tries to put the logic into proxies, and we have those proxies running in front of the microservices, and the microservices and the proxies, they run on top of Kubernetes. I mean, we're at KubeCon now. And the benefit now is it's decentral. It's language agnostic, because the proxy doesn't really care about which programming language you use for implementing your microservices. It's polyglot, any language you can use, and you don't have to change the microservices. And it's lightweight. You might be a bit worried about seeing all these proxies now, like one proxy for every microservice. But let me explain this a bit later. This is how it goes. We really have one proxy for every microservice. Now, if you looked into this technology before, you probably know Istio and Envoy. That's maybe the most popular one, the open source solution that you can use and get started today. So if you have two services, like one is a product page service, and that's the Hello World example that comes with Istio, that is talking to a review service. The way it goes is the product page service wants to talk to the review service, but they talk through the proxies. So the proxies, again, intercept the invocation. And those proxies, they live in the same pod. And because they live in the same Kubernetes pod, they share the same namespace, and this is because they can intercept the communication. This is working for different protocols. It's working for HTTP, HTTP2, gRPC. It's actually even working for DynamoDB, so there are customers that use this to intercept DynamoDB calls. And that's the proxy side, and that's the side that is running close to your microservices. And then there's the control plane. And I don't want to go into many details, but the control plane is basically instrumenting the proxies, steering the proxies, telling the proxies what to do. And it's also retrieving metrics from the proxies. Imagine everything is going through the proxy. The proxy is a fantastic point to collect metrics, because every invocation is going through those proxies. And that's the other part of the other responsibility of this control plane. And then it's obviously also possible to inject certificates and to create TLS communication. That's the third part that this Istio service mesh is doing. So Istio is kind of the control plane, and the proxy that is running close to your service is called Envoy proxy. And now if you want to do some magic in quotation marks and say, like, remember I told you about the ESB that switches based on some criteria from version 1 to version 2? With this small YAML file, which is 17 lines, you can specify that if you call the review service and you use HTTP, and then 97% will go to version 2, but 3% will go to version 3 of the review service. And all you do is kubectl apply -f from this little YAML file. And this is how it goes. So that's open source Istio service mesh. It connects, secures, and observes services. And the important thing from an architectural perspective is it kind of shifts where you locate the functionality. You don't put it in a library into the service. We don't have the big monolithic service bus anymore. It's in small proxies in between. And the control plane is Istio. This is what controls and steers and configures the proxies. And then we have the data plane, which is the set of all Envoy proxies together. And those Envoy proxies, if you wonder like who's going to start 117 proxies for 117 microservices, they live in the pod, and they can be, well, created manually, or they can be injected automatically into this Kubernetes pod. Both is possible, and actually both is possible today with EKS. Envoy itself is, in my opinion, great piece of engineering. So if you have some time, go and read up about Envoy. It's a level 7 proxy. That means it understands the level 7 network protocols. I already listed them. Maybe you were wondered about, having 117 proxies running for 117 microservices. The size is 8 megabyte. It's statically linked C++ code. If you think for a moment, 8 megabytes, how much is it? It's like 1/20th of the size of a JDK download. So it's like very, very small. And I think the RAM overhead is not really a big concern. You have no language or framework dependencies. It's just working for any kind of language. Actually, the Hello World example that comes with Istio and Envoy is written, I think, in like 5 different languages. And no code changes. You just run the proxies, and it intercepts your calls, and it will work. It's battle-proven. Lyft uses it for millions of calls every day, and more customers use it. And it's actually not tightly coupled to Istio. We always hear this Istio-Envoy thing together, and it seems like a married couple, but it's not so tightly coupled or married. There is some flexibility. And now you might still think, like, Is it a thing? Is it really, are people using it? As a big surprise, and this just happened last week, something happened. Do you know this Netcraft study that finds out how many people are using which web server? Like the top 10 web servers are used. They give you statistics like this, and you can see the blue line is Apache if you can't read it. It goes up and down a little bit, and Apache is going down for some reasons right now. But for the first time, actually Envoy showed up in the statistics. And if you do a little bit of research, you will find that there is so much happening with Envoy right now. So people building load balancers with Envoy, people are building API gateways with Envoy. Envoy is used a lot, and the amount of usage increased by a factor of 500, and this is why it, for the first time, a bit surprisingly, showed up in this Netcraft study. Okay, so maybe some people are still skeptic and think like, what is he talking about? Couldn't all this not be solved with Kubernetes? And let me explain a little bit more about updating and upgrading systems. And I guess you all know this blue-green deployment, don't you? This is the original graphics that Martin Fowler produced. And I had projects like this many times, and I like to call them crystal ball projects, because people in my previous life, they hired me to predict, like, if we change from blue to green, from version 1 to version 2, can you predict, like, if we do this in 1 year and we have this amount of increased traffic, what hardware should we buy? Because if you switch from blue to green, you need a second set of hardware. If your first set of hardware costs you $1 million, you spend another $1 million. And this is like really ancient times. We don't even want to talk about this. Now, if you do the same thing in the cloud, the update strategy gets easier, because you can have this second set of hardware only for the amount of time that you need it, and you then actually at the end pay per second, and it gets much, much cheaper. So that's a rhetoric question. Do you like cold water? I hate cold water, I have to tell you. If you do this blue-green deployment, you throw your customers in cold water. No, I mean, you go from blue to green, you test green before, but at some point there is this big switch, and you flip the switch, and it goes from blue to green. And if you have 10,000 customers, all 10,000 are working with the green environment. So basically, it's 100% this switch over, and you better have a good fallback strategy if, despite all the testing, something goes wrong. No. Now, this is KubeCon, I know. You will say, yeah, but we can do rolling updates with Kubernetes. And I tell you, yeah, I know. And if you do rolling updates with Kubernetes, and you run your application, let's say, across 4 pods, you upgrade 1 pod. So it's like 25% change. And look at this. It took me a lot of time to create it. I didn't do it for the other 3. So you change from 25 to 50 to 75. For 10,000 customers, you still throw 2,500 into cold water. Do you want to do this with your customers? Well, the thing is, like, if it's just 4 pods, the minimal thing that you can change is 1 pod. No, it's 25%. And that's it. So it's a rolling update. I think it's deprecated now. It's called rollout in Kubernetes. It's 1 pod at a time. But how about not having a bathtub full of cold water, just like wetting your feet a little bit? How would you do that? Like, how getting these 3%? And that's when the service mesh comes into play. Remember when I showed you can do this with Istio and Envoy? That's a basic use case for service mesh. And I think there will be more live demos later on. So maybe somebody's showing you this as well. But this little bit like traffic shifting instead of pod deployment, that's the thing. So you will hear a lot of people telling you, well, Docker can do this, Kubernetes can do this. Well, they can do rolling updates. And I was doing this at the end. I told you that I failed with my Kubernetes cluster at home. At the end, I was running Docker Swarm. And it did this rolling update beautifully. And I was very proud to show it to people. That was kind of the highlight. But I didn't get this traffic shifting. So if you want traffic shifting and separating traffic flow from replica deployment, that's one of the core use cases for using a service mesh. So if you want to do Istio and Envoy today, you can do it on EKS. And this gets you into this world of the CNCF, the Cloud Native Compute Foundation. where we have Kubernetes and we have Prometheus and where we have Envoy as the graduated projects, which means it's like a little bit of a safety mesh, that tells you out of those hundreds of open source projects, the graduated ones are used by a number of companies in production. And there is those incubating one that are getting closer to being graduated. But as you see, Envoy is in this list now, and also Prometheus and certainly Kubernetes. So again, this could be the end of the story, but it's not, because if we speak to customers, they ask us for more. They say, look, we see now the use case for running a service mesh on top of Kubernetes, and we could do it manually ourselves. But how about having a service mesh for all the compute services? Remember on the second slide when I told you, there is like EC2 still around, there is EKS still around, there is ECS, there is actually ECS with Fargate. This is what you can do with AppMesh. So AppMesh lets us use a service mesh across ECS with Fargate, which is the serverless ECS where you don't provision the worker nodes, EKS, Amazon EC2. You can run it on EC2 even without Docker containers, just pure EC2 and applications. Or it could be Kubernetes on top of EC2, like the self-managed Kubernetes. And all this is done with AppMesh. Now, interesting is AppMesh is using the Envoy proxy. Remember, I told you all the benefits of using Envoy and why it's so popular and how many companies are using it, and it's showing up in this Netcraft study. We also use the Envoy proxy because we think it's the best. It's the motor at the end that is doing all the interceptions and executing everything. I think it's the best choice. So it would be foolish not to use it. But we're not using Istio. That's the other thing you need to understand. And why are we not using Istio? Because we want a service mesh that is working across all these services. This is because it's AppMesh, but AppMesh is working together with Envoy. And to get started with AppMesh, there is a command line. There is it's in the console. There is a SDK, obviously. It's free, so there's no reason not to try it. And it supports any third-party tool that works with Envoy. Now, how to get started? Okay, you probably know that we are very keen on documenting things on a very detailed level and give you a lot of choice and a lot of low-level granularity of what you can do. So there's different ways of getting started with AppMesh. And I think the most popular one, it just came out last week, and this is why I'm super happy to present it, is the following. You get EKS quickly. What's the best way to get started with the EKS cluster? It's actually EKS control. It's an open source project. It gives you a command line, basically what you say, EKS control cluster, and then it will create a cluster in your region. If you want to give it a name, you give it a name. If you omit the name, you get a funny name, like those funny names that we have for Docker containers. I think my last one is called Beautiful Paintings. So that's the name of my EKS cluster. And if you say ---- AppMesh access, you also enable the node groups to access the AppMesh API easily. So it solves you a lot of thinking. I'm the person that believes you should have a really easy start. I believe in these MVP, minimal viable products. And I think we also should have like minimum viable demos for customers. So getting started with EKS control with an EKS cluster, I recommend to do this. And then you will have your cluster up and running after a couple of minutes. And now we have a Helm chart. And I think most of you know Helm is like the package manager for Kubernetes. And all the credit for this Helm chart and also for the next slide, it actually goes to a colleague of mine. He's a principal SA for containers, Paul Maddox. So if you ever see this recording, he deserves all the credit because he built this Helm chart. And with one single Helm chart, you can now install AppMesh, which actually installs AppMesh with Envoy. It gives you the X-Ray daemon sidecar and also the statsd exporter for Prometheus. So one single Helm chart installation gives you all the magic. And look again, it gives you X-Ray and it gives you Prometheus. So talking about this CNCF thing, for a lot of people it seemed like, either this way or using the AWS services like X-Ray and like, CloudWatch. It's not either or. You can pick the best one that you like. And in this little demo, it's a demo, no, don't use it for production. But in this demo, it installs both. And you can play with Grafana if you want, and you can play with X-Ray at the same time. So it doesn't have to be either or. It's not like a very tough decision. You can do whatever you want. You can choose. And the second part is actually even more interesting. This is where you install a small demo. It's a little demo that is using, I think it's 3 pods generating load and sending the load to 2 Nginx pods. And that's it. That's the whole demo. But you can install it and make it run with this Helm install and see if this is working. Yeah, that's the interesting part. This is where you first create a namespace, which is called AppMesh demo. And then this is the magic where we label the namespace AppMesh demo with this sidecar injector webhook enabled, which basically means whatever you deploy in this AppMesh demo namespace gets those sidecars injected. And because we have StudsD and we have Envoy and we have X-Ray, it's actually 3 sidecars. You don't need all 3. You can disable them if you want. But in this case, you will see 4 containers running in 1 pod. And this is the magic how it happens by setting the label on the namespace and then deploying into this namespace. And yeah, if you do this, I have it live running, but I think it's easier just to show you the screenshots that I took like yesterday. You get observability with X-Ray out of the box. So you see your services, you see the invocation times, you see which service is invoking which service. It's probably too small to read it here, but if you come closer, you will see that the load balancer is obviously invoking the Nginx service. On the right-hand side, you just see the distribution of the response times. If you go into the traces, you see the traces, like those inverted flame graphs that you might know with the execution times and how they consist of the different services invoked. Then we can show you the response time percentiles, like how much of the response time is in the P50 or P95 percentile. And that's the part that you get from the operations side with X-Ray. If you switch to Grafana, we have it's pre-configured already. It comes with an overview dashboard that gives you an overview of Istio. So you see the top 5 services by request, by the number of requests. And you also see the worst 5 services by the number of HTTP, I think 400 and 500 responses. And then you can drill into a service view where you get the service view, in this case, for the load balancers and for the Nginx. And you get the requests per second and some more details. And you also see that this was running for a couple of days. So this is not just it's still running. So if you want to see it afterwards, I'm happy to show you while having a coffee. So it's still running and it works beautifully. And in my opinion, that's a cool way to get started and to get your hands dirty and to play with it. And maybe the next thing is not to deploy this demo, but to have AppMesh up and running with the first Helm chart and then deploy your own demo. As I said, I'm a big fan of having the smallest working demo that kind of makes sense. So using AppMesh, you get observability. I highlighted here the AWS options, like it gives you CloudWatch logs, it gives you CloudWatch metrics, it gives you X-Ray for tracing. Then we also do traffic management. We do traffic shaping, like the example I showed you on the Istio side, 95% and 3%. You can do exactly the same here. So you get load balancing, you get weighted targets, and the whole thing is path-based. That's the typical examples that we can do right now. The one with the asterisks are the ones that are coming. Now, since it's not using Istio, also the concepts and the constructs are slightly different. So if you start, you really define a mesh. You give the mesh a name. And the mesh name is like a logical boundary for the network traffic. It's all the things that belong together, the services that belong together. But again, this mesh can span across different compute services. That's the exciting thing. Then we have a virtual node, which front-ends a real back-end service. And we have routers and routes that define the routing. And then we have a virtual service that basically where dependent services that you call use this virtual service name. So these are the constructs that you need to understand that you will find again in the YAML files if you set it up. And then I told you about the proxies that we can inject automatically, the services that you already know, and there's service discovery with AWS Cloud Map. There is a page on the console if you go to the AWS console, and if you have your demo app deployed with the Helm chart, you will see it on the console, obviously, and you can dig into those constructs and reverse understand them, reverse engineer them. The roadmap is public, so if you have any feature where you think we should implement this and we've forgotten to think about it, or if you want to push any feature, this is the link to GitHub. We are working with a number of partners that are all listed here. Some of them are here, they're presenting, they already presented or will present afterwards. And this gets me to the summary. The first point is architect wisely. That's a very general advice, I know. But it means don't trust the people that tell you everything should be containerized or everything should be AWS Lambda. It's not. It's your job as an architect to decide what's the best solution. And sometimes the best solution might be even EC2. It changes over time, but it's your task to decide this. The next one is remember my bitter experience. Running Kubernetes is hard, and I'm not alone in this. I have super experienced colleagues that say, Kubernetes can make grown-up men cry. Sometimes it's incredibly hard, and you sit there and you think what is going wrong? No. So don't do it yourself. Let us do it. No, we put a lot of expertise and a lot of knowledge in, and this is why we have EKS. So use a managed Kubernetes service. That's really one of my advices. If you go for EKS, you can also use everything that comes with the CNCF. So it's unforked upstream Kubernetes. That's what customers tell us. Don't change it. Don't make it different. We want standard open source Kubernetes. That's what you get with EKS. A service mesh, I was trying to explain this here, it complements Kubernetes. It's not things that were forgotten in Kubernetes. We used the ways to extend Kubernetes, and it's working on top of Kubernetes to give you those additional benefits like observability and traffic management. Service mesh is free, and it works across compute services, so I think there's no reason why you should not try it. As I said, the easiest way to get started is using those two Helm charts and to play around a little bit. Again, all the credit goes to Paul Maddox for creating them. I think that's super important to mention the people that do the hard work and make those complicated things easier for all of us. We have a great recording from another colleague of mine that digs into AppMesh much deeper, that also shows you working AppMesh across different compute services. It's a recording from the AWS Summit, I think in Anaheim. It's linked here. And I did another presentation about using Istio and Envoy on top of EKS, which is linked here. You don't need to take pictures. I mean, if you want, you're very welcome. But I uploaded the slides already on Speaker Deck, and they will be shared by AWS as well. So you will have those slides for sure, I promise. And with this, I want to say thank you. If you want to connect to me. I'm a friendly person. I'll be around for questions outside. I think we are a bit behind in time. So thanks for listening. You've been a great audience. Thank you.